Hey friends, it's Ben again. This is a video for Calculus 1. This is getting ready for assignment number 7. Assignment number 7, I don't remember what the section number is, but the title for it is Infinite Limits. So with regard to that, we have two different things to deal with, and they both boil down to the notion of asymptotes. So we have to deal with both the notion of a vertical asymptote and a horizontal asymptote. Vertical asymptotes are going to happen when you have some kind of a division by zero sort of thing happening in the numerator, but not the denominator. If there's a zero in both the numerator and the denominator, then you should be able to factor and cancel. And we looked at that with assignment number 5. So now we're going to look a little bit at what we do on those things when you don't get the cancellation. And so, hoping that the share screen works out this time around. So, yep, it's going to work. All right, so these are your basic rules here. You've got something on the top and the bottom of your function, and the top part is not going to 0, but the bottom part is going to 0, okay? So then we're going to have to talk about the one-sided limits. And when you talk about the one-sided limits, most of the time you're going to have to take a look at a graph to say something. And in order to show your work on that, you have to sketch the graph. If you want to copy and paste it from Desmos, you can get a super nice looking graph, but really just sketching a quick graph and saying, hey, look, it went to infinity on the left side or the right side. So if the two limits are going the same direction, if they're both going to plus infinity or they're both going to minus infinity, then you can say that your limit is going to be plus infinity or minus infinity, whatever it's going to. But if they disagree, if they're going to different infinities, then we go ahead and refer to that as a limit does not exist. And go ahead and say if you're asked, say that you have a vertical asymptote. And I suppose that I should have said a vertical asymptote at x equals a. Okay. So that's the thing that we'll deal with there. And then we'll come back and talk about horizontal asymptotes in a minute. So with this limit that we're looking at here, one thing that you might be motivated to do is to try to factor it and cancel it because it looks like one of those problems. So when you do that, your bottom factors as x plus 4 times x minus 2, and your top has x plus 1. You might be tempted to try to cancel the x and the x plus 1 with the x and the x minus 2. If you do that, you have problems with your algebra. When you want to cancel from a numerator to a denominator, it has to be something that's multiplied. So it has to be a factor of the whole top before you can cancel it with something on the bottom. There's no cancellation going on here. So we need to take a look at a graph of this. Fortunately, I have Desmos on here, and hopefully if things worked out right, y'all got Desmos pushed out to your iPads. So I'm just going to graph, it's got an x plus 1 in the numerator and x squared plus 2x minus 8 in the denominator. So if you're taking a look there, you will notice that now at your x equals 2 here, I guess I could go ahead and put x equals 2 in the graph there. So if you're looking at that, then on the right-hand side, because we're taking a limit, we're going to have to take a limit on both ends of it. On the right-hand side, it's going up to plus infinity. On the left-hand side, it's going down to minus infinity, okay? So that tells us that this limit we're taking is not going to exist. And we have to write down our reasoning. In case I have not made that clear, that is the most important thing in math, is to explain what your reasoning is. So this went downward on the left-hand side, and on the right-hand side, it went upwards. So the limit as x goes to 2, without saying left or right, does not exist. Okay, because those limits on the left side and the right side do not agree, that says your limit does not exist. All right? Okay, then let's take a look at another one here that we're going to have to look at a graph of. And this is dealing with cotangent of x. Now, if you don't quite remember cotangent of x and what the graph looks like, it is 1 over tangent x. That probably helped you about as much as it helps me. So let's see if we say to graph cotangent of x. By the way, notice here I've got this option of tan inverse. Tan inverse is not cotangent x. We need cotangent x, and now we get a graph of it. We are in particular interested in what it looks like around x equals pi. Let's see, where are the, there. And if you're looking at that and it's a little hard to see, then we can go in on that and make it a dashed line, okay? So it looks like to the left of pi that we are having it go to negative infinity, and to the right of pi, we're having it go to positive infinity. So that means we have to go back and look. We wanted it to the right of pi. So for our answer here, we will just say positive infinity. And we ought to, oh, I forgot in the previous one to do this. We ought to give a little bit of a sketch of what's going on so that it's illustrating what is happening here. So x equals pi. Okay, and I'm going to go back on the previous one and give a brief sketch of what that looked like as well. And unfortunately, I am going to pause this for just a second so that I can just draw that and you don't have to watch me draw it. So. Okay, so coming back here real quick, you can see that for the previous one, I drew something where you can see the asymptote. I did not try to draw it super neat or anything. Totally fine to do that. Same sort of thing here for our cotangent x. Just give me a brief sketch of what it was that you saw when you graphed it. You can use Desmos or any other graphing calculator you want to deal with, okay? All right, so now we need to deal with what is going to happen with the horizontal asymptotes. And the whole thing with them could be kind of boiled down to the notion that as x goes to infinity, that 1 over x is going to go to 0. So if you've got x to some power and x is going to infinity, then you know that you've got infinity if you get a positive power. But if you get a negative power, then you're going to have to do something with negative, or you're going to have to do something with the limit being 0. Okay. Similarly, we have limits going on with exponentials. Your exponential graph looks somewhat like this. And I'm not attempting to make a very sophisticated graph, but that's roughly what an exponential graph looks like. So off to the right, it goes to infinity. To the left, it goes to minus infinity. Your logarithms are really very similar to exponentials, just rotated around a different direction. And so as you go off to the right, x is going to positive infinity, log goes to positive infinity. But as x goes to 0 from the right, log x goes downward to minus infinity. Those are just super rough graphs, okay? So first question we're going to look at is how to evaluate the limit of the logarithm of the absolute value of x. Now, you know that if x is positive, what this is going to look like. So I'm going to try to draw just a brief sketch of that. And then I'm going to be totally unimpressed with my drawing skills. Yeah, there we go. But that's what the log of x should look like, right? So then if I talk about the absolute value of x, that should then take the picture of the positive side and just draw it exactly over on the negative side. So yeah, my picture's not all that great, but now you can see that the limit as x goes to 0 from the left of the log of the absolute value of x is going to be equal to minus infinity, and the limit, and I wrote too much on one line, the limit as x goes to 0 from the right of the log of the absolute value of x is going to be equal to minus infinity. So the limit as x goes to 0, not one-sided, but just in general, is going to be equal to minus infinity. And I am going to take and move those down here. Okay, you explain your reasoning on these things. And having the graph will allow you to easily enough make reference to these portions of it, okay? This one portion here, you could have said that's a special limit and just expressed it like that, but it's also a graph that's easy to make a quick sketch of. All right, here is something that if you've seen these in a pre-calculus class or something, that this is what you've dealt with. If you've got polynomials on the top and the bottom, and you've got your x going to infinity or minus infinity, you have 3 cases. Either the degree on the top and bottom is the same, or the degree on the top is smaller, or the degree on the bottom is smaller, okay? I'm trying purposely not to give you whole bunches of different cases to memorize. Instead, if you run into something like this, divide the top and bottom by the largest power of the bottom. Okay, that's not ambiguous. It's always the largest power on the bottom. So you end up multiplying this top and bottom by 1 over x squared. When you do that, you have a limit as x goes to infinity, and we're going to have x squared over x squared minus x over x squared minus 12 over x squared. That's the top. Then the bottom will be 2x squared over x squared plus x over x squared plus 8 over x squared, which you can simplify as 1 minus 1 over x minus 12 over x squared divided by 2 plus 1 over x minus 8 over x squared. Okay. Now, the reason that you want to do that is we just got through giving this principle that 1 over x goes to 0 as x goes to infinity. So that means we can just evaluate 1 minus 0 divided by 2 plus 0 minus 0. Bam, there's your limit, okay? If you know the rule about dividing the leading coefficients, great, you can use it on this one. On the next one, you may not be able to, okay? So if y'all are good with that, that doesn't require a graph. That is going from this first principles sort of thing that these limits here are a special limit that we're allowed to just kind of remember. All right, so here's a similar sort of problem. And this time the degree of the numerator and denominator are not the same. So you can't just divide lead coefficients. You have to, on the top and the bottom, divide both of them by x squared because that's the largest degree on the bottom. So this becomes a limit as x goes to minus infinity of minus 2x cubed over x squared plus x over x squared divided by x squared over x squared minus x over x squared plus 1 over x squared. And that simplifies to minus 2x plus 1 over x, I said x squared, it's just 1 over x, divided by 1 minus 1 over x plus 1 over x squared, okay? And now we get to just plug in. Now, all of these that have the 1 over x sort of stuff in them, all of those go to 0. So this limit you can think about as being minus 2x over 1 because all the others have gone to 0. And as x goes to minus infinity, minus 2x is going to go to plus infinity. Okay, bang. That's all you have to do. If the degree of the numerator was smaller instead of the degree of the denominator, then as you went along with this, you would end up getting 0 out as your limit. But in any case, this method of just dividing top and bottom by the highest degree in the denominator always works. And it's just one thing to remember. So, yay. All right, here is one that is kind of painful. So we have a limit as x is going to infinity, and we've got 2 square roots. So if you just plug in, because I always tell you, try plugging in, this is going to go to infinity, and this is going to go to infinity, but we're subtracting them. Sometimes when you subtract infinities, you get infinity. Sometimes you get 0. Sometimes you get 17. It could be anything. So we've got to figure out what to do on this. And the trick is to view it as a fraction, okay? Remember what we did when we had fractions in these limits and there were square roots that were subtracted? We did the whole trick of multiplying by the conjugate. So I am going to take on this bit here and just take off those parentheses because they're kind of in the way. Scoot this up a little bit. I'm going to multiply the top and the bottom by the conjugate. And that is going to be a plus square root of x. Notice that I did not change any of the signs under the square root, okay? But now, the limit as x goes to infinity, your numerator up there will turn into 2x squared minus x because of a difference of squares. And your denominator will have this square root of 2x squared plus x, and then plus a square root of x, okay? Now, as x is going to infinity, that numerator is going to infinity, and so is that denominator. So it seems like we're still stuck. But one of the things I'm always trying to do, I'm trying not to work the easy problems for y'all, but rather to show you ones that have a couple of steps in them. So this, we're going to have to think about how to multiply the top and the bottom by, or to divide the top and bottom by the power of the bottom. The bottom has a square root of a square. If it was just the 2x squared, we would think about it as being power 2. But since it's the square root of 2x squared, we're going to think about instead multiplying top and bottom by 1 over x, okay? So then I'm going to say times 1 over x and 1 over x, limit x is going to infinity. The top will turn into 2x squared over x minus x over x. Not too hard to deal with. Oh, the bottom though. Now you've got to think about 1 over x being multiplied by that 2x squared plus x. And you also have to think about 1 over x times the square root of x. So when you pull something into a square root, you have to square it. This is like if you take the square root of 4 times 5 is the same as 2 times the square root of 5, okay? So we're pulling, instead of pulling that square out, we are putting something in. So here, putting it inside, you'll have 2x squared over x squared plus x over x squared. And then plus a square root of x over x squared. And up here in the numerator, this turned into 2x minus 1. And now limit x is going to infinity. And here we will end up with a 2 plus 1 over x plus a square root of 1 over x. And then up there in the numerator, it's 2x minus 1. So when you plug in the infinity, the 1 over x stuff turns into 0. But when you plug in the infinity for the x, you're getting an infinity. So here with this, we have to think a little bit about it, that we have a positive something times a positive infinity. So I'm going to write, I'm going to write plus infinity there. And then on the bottom, I'm going to go ahead and write square root of 2. But then I'm going to write positive infinity as my final answer. If other math teachers were around, I would have to not write this part because they would be all embarrassed at me and stuff, because infinity is not really a number. You can't really divide it, but it's helping us see that we're dealing with positive stuff because we're multiplying by a positive number. Okay. All right, I think that should get it for y'all. This is assignment 7, I believe. And so that's what we're looking at on Wednesday. Make sure and ask any questions that might come up in the Canvas assignment, and I'll try to answer those at the beginning of class, and then we'll get you going. All right. See y'all on Wednesday.